Welcome to the lesson on quadrilaterals and its types. At the end of this lesson, you will be able to identify different kinds of quadrilaterals based on their shapes. You will also be able to verify properties of various kinds of quadrilaterals and the angle sum property of a quadrilateral. Look at these points on a plane. Consider any 4 points such that no 3 points lie on the same line. Join the points in a clockwise or anti-clockwise direction. What do you obtain? A 4-sided closed figure. This is called a quadrilateral. A quadrilateral has 4 sides. Here AB, BC, CD and DA are the 4 sides. For angles, angle A, angle B, angle C and angle D are the 4 angles formed at the vertices. And for vertices, A, B, C and D are the 4 vertices. AC and BD are the 2 diagonals of the quadrilateral ABCD. Next, we'll discuss about the different types of quadrilaterals and their properties. Quadrilaterals can be classified into different types based on their sides and angles. Let's learn about each of these quadrilaterals. You are already familiar with the first 2 quadrilaterals. Yes, the first quadrilateral is a square and the second is a rectangle. Each angle of these 2 quadrilaterals is a right angle. Also, the opposite sides in each case are parallel. The difference is in the lengths of their sides. A square has all sides equal in length, while a rectangle has opposite sides equal in length. The diagonals of squares and rectangles bisect each other. In case of a square, they bisect at right angles. Thus, a square is a rectangle with adjacent sides equal. Next, let's consider the third quadrilateral. If we compare it with the rectangle, we see that it is different from the rectangle in terms of the measure of its angles. Its angles are not right angles. However, the opposite angles are equal. Such a quadrilateral is called a parallelogram. Let's define it. A parallelogram is a quadrilateral in which opposite sides are parallel and equal in length. Opposite angles are equal. Diagonals bisect each other. Now, consider the 4th type of a quadrilateral. On comparing this quadrilateral with a square, we find that most of their properties are same. However, unlike the square, its angles are not right angles. Such a quadrilateral is called a rhombus. A rhombus is a quadrilateral in which all sides are equal in length. Opposite sides are parallel. Opposite angles are equal. And diagonals bisect each other at right angles. Thus, we can say a square is a rhombus in which each angle measures 90 degrees. Now, let's consider the definition of all 4 quadrilaterals. Can we say that a square, a rectangle and a rhombus are parallelograms? Yes, we can. Squares, rectangles, and rhombuses are all examples of parallelograms. Thus, squares, rectangles, rhombuses, and parallelograms can also be defined in terms of quadrilaterals as shown. The relation between these can also be represented as shown. Now let's consider the remaining quadrilaterals. Both these quadrilaterals are quite different from the ones we have just learned. This is a trapezium. It is a quadrilateral in which one pair of opposite sides is parallel. Now, here's a special trapezium. Its non-parallel sides, as you can see, are equal in length. Similarly, if you measure the base angles, you will see that both are equal. Thus, a trapezium having non-parallel sides equal and base angles equal is known as an isosceles trapezium. Now, let's consider the last quadrilateral. Does this shape look familiar? Yes, it is similar to a kite you must have seen flying in the sky. This quadrilateral is called a kite. Let's learn more about a kite. A kite is a quadrilateral in which two pairs of adjacent sides are equal in length. And one pair of opposite angles, the ones that are between the sides of unequal length, are equal in measure. Also, one diagonal bisects the other. And diagonals intersect at right angles. Now, let's prove a property which holds true for all types of quadrilaterals. Do you remember the sum of three angles of a triangle? Yes, it is equal to 180 degrees. Using this property of a triangle, we will show that the sum of four angles of a quadrilateral is equal to 360 degrees. Consider a quadrilateral. A diagonal divides it into two triangles. Since the sum of three angles of each triangle is 180 degrees, the sum of the angles of a quadrilateral is equal to 360 degrees. Let's prove this theorem. Consider quadrilateral ABCD. Let AC be its diagonal such that it divides the quadrilateral into two triangles, triangle ABC and triangle ADC. Sum of three angles of a triangle ABC is equal to 180 degrees. That is, angle BAC plus angle B plus angle BCA is equal to 180 degrees. Similarly, the sum of the angles of triangle ADC is equal to 180 degrees. That is, angle DAC plus angle ACD plus angle D is equal to 180 degrees. Adding equations 1 and 2, we get the sum of the angles equal to 360 degrees. But angle DAC plus angle BAC is equal to angle A. Similarly, angle ACD plus angle BCA is equal to angle C. This implies angle A plus angle B plus angle C plus angle D is equal to 360 degrees. Thus, the sum of the angles of a quadrilateral is equal to 360 degrees. That is, the sum of all the angles of a square, a rectangle, a parallelogram, a rhombus, a trapezium, and a kite is equal to 360 degrees.